Hi, and welcome back to Let's Code Season 6. Before I get started, I just wanted to say a huge thank you to members and patrons. Your contribution is always appreciated, and if you are interested in supporting the channel, then by all means become a channel member by hitting the join button. Channel members get early access to all of the videos in this series and all future content as well. So well worth doing if you want to get ahead of the game. Okay, jumping into this. In the last episode, we did a whole bunch of stuff around the entity class, but in this episode, the first thing I want to start off with is making some changes to our game room class, because what we need to do is make sure that when we know what our entrances and exits to the room are, so wherever our exits exist, we need to create a little anti-spawn cordon. We need to reserve some tiles so that when the player enters the room for the first time, he doesn't, or she, they don't enter the room straight on top of one of our entities. This is only for spawning, because once the player is in the room, it doesn't matter where the enemies go, as long as they stay within the grid, obviously. But for that initial period, once the player enters the room, we can't have those enemies being right on top of them, because that would be unfair. So what we need to do is we need to, in some way, reserve some tiles. So what I think we're going to do is we're going to create a list inside our properties, which will contain a list of reserved tiles based on where our exits are. Our exits are always going to be smack dab in the middle, obviously if it's an odd number of cells across. But as you can see, our exit is actually an even number, which means that our middle is actually 2 tiles. So what we need to do is make sure that the center tile and 1 tile either side of it are completely reserved, and potentially the one below it as well, or the one to the right of it, depending on where the entrance or exit is, just to make sure that there's no issues when the player enters the room. So the first thing I think I'm going to do is I'm going to create a new property using a decorator. And we'll just call this get reserved tiles and self, like so. And I need to put a DEF at the start of that, define, otherwise it's all going to go horribly wrong. So what this will enable us to do is to just call this, and it will return a list of all of the cells which the mobs cannot spawn in, and basically anything in the entity class cannot spawn in. And the game object class can't spawn either. But as you can see, these classes don't control where they spawn. It's actually the room class that does it. So we're creating a property from within our class that is going to be used only by the methods in the class. So we don't actually need to change where we are working. So I shall just zoom in here so that you can see what we're doing. So we've got a property called get reserved tiles. Now the next thing we need to do is we need to ascertain where our entrances and exits are. Now we've already done that at the top of the class, because we've got exits, and the exits themselves are determined by the map class when we create a room. So if you remember, if we come back to the map class here, we have the thing that passes the entrances and exits into our game room class. So we already have a list of game rooms here. And get entrances and exits here is a method that turns the binary data that we've input. So remember, we put 1, 2, 4, and 8 as our door numbers, and then we just add the numbers together. And what I've done here is I've converted that number into a binary number, so 1, 2, 4, 8, or whatever the number we've input in. And then what we do is we split the string down into 0 and 1, and if there's a 0 in the first position, then it has a west exit. If there's a 0 or a 1 in the second position, that's the south exit. A 1 in the third position is east, and the 1 in the fourth position is north. So that just gives us our list of entrances and exits. So we've already got the method that's telling us where our entrances and exits are. What we now need to do is use that information. So let's start off with we'll start off with the north exit actually. So what I first need to do is say if north in get exit list. We don't need parentheses, but we do need to say self.getExit list. There we go, self.getExit list. And if we're not sure about spelling, you can always just copy and paste. Sometimes I do that just to make 100% sure, the methods are right next to each other, so you wouldn't think it'd be that difficult, but even I make typos on this every now and again. Okay, so we're saying if north in self.getExit list. Now what I need to do is determine what the center tile is. We already know what the top tile is, so the y is going to be 0. But we need to find out what the length of our x is. So we need to firstly divide that by half. So we need to say, let's just say x equals self.getSize divided by 2. Now there is a problem with that, so we need to actually round this number, because if it's an odd number, that's actually going to be a 0.5 number and not a whole number. So in order to do this, what we're actually going to do is we're going to use the math.floor function. So we're going to say math.floor self.getSize divided by 2. And what this does is it rounds the number down. The reason I'm rounding down and not up is that if we divide, let's say we've got 9 tiles. If I divide that in half, what it's going to say is that our center tile is going to be 4.5. And I'm just having a second guess on myself now, because the center tile of that is actually 5. So what we need to do is say ceiling instead. So we're going to say math.ceiling. So we're going to round up. So if it's 10 tiles, then 10 divided by 5 is the 5th tile. That's not the end of the world. It's not great because it's not smack bang in the center. It's actually kind of slightly to the left of center, but we can live with that because at least it's a whole tile. But if we have 9, what we want to do is to say the center tile is 5, and then we could perhaps put a rule in that says the center tile, or the integer variable for x and y, has to be an odd number. It wouldn't be the end of the world if we just made sure that all of our map grids, all of our rooms were an odd number of tiles across. But we'll deal with that later. This will work, the point is. Okay, so now what we've said is that our x coordinate is the center tile. We've rounded it down or rounded it up using the math ceiling function, which will allow us to do that. So now what we need to do is we need to create a list of tiles that cannot be spawned in. So we just need to say we need a list of anything else. So we need to just go to the top here, and we're going to create an empty list. So we're saying output list. Helps we spell list correctly. There we go. So now we're going to append all of the cells that can't be spawned into this list. So what we need to do is say output list.append, and we need to create a tuple. So we know what our x is and we know what our y is for the tile itself. So we'll start off by doing that. Now, remember that our matrix at the top here is y dominant. It doesn't matter whether we make these x or y dominant. We just need to make sure that we're consistent so that we don't accidentally get ourselves in a muddle. So I'm going to leave this as being x dominant. So we're going to say x, 0 is going to be our first cell that cannot be spawned into. Now I could do all this in one line, but for the sake of readability, I'm actually going to do each cell in its own line. Otherwise, we might get lost. Okay, so I'm just going to copy this line. We need 4 tiles in total. The cell itself, the cell to the left, the cell to the right, and the cell below. So we're now going to say x minus 1, x plus 1, and last but not least, x, 0, x, 1. Okay, so those are our cells that will be reserved, unspawnable, when we have the exit to the north. Now all we need to do is copy this and paste it, and we're now going to do the south exit because that's an almost carbon copy of the lines that we have here. So we're now saying if south in exit list, we use the same function for our x of the cell that we want to reserve. Now though, we need to say self dot get size -1, because remembering that get size gives us the the size of the list, not the index of the top row. The top row index is always going to be 1 less than the size, because the first cell in our list is position 0, not position 1. Hopefully that made sense to you. You've probably figured out by this point how lists work. A list of 10 will be 0 to 9, not 1 to 10. So we need to subtract 1 from the length of the list, otherwise it will give us an index error when we try to do this. Next thing is the x -1. So we're just going to copy this and we're going to replace all of our zeros with it. And then in this one, because we're now doing the cell above the one that we're in, we're going to say get size -2 instead. So that is our south exit. Diggity diggity done. Now we need to do the same thing for our east and west. So we're going to copy this anyway, because a lot of the code is going to be the same. It's just we're changing the cells that we're looking at. So we'll start off with east. So we're looking at the right hand side of the screen. So now we need to say Y. And we also need to adjust where we're saying get size, because get size actually returns a tuple. So it is going to be an X dominant tuple. So I actually need to change this to be 0. I'm just going to copy this. Or I could create a new getter that just says get size X. That would make life easier, rather than having to refer to the indexes. Yes, let's do that. Okay, so we've got get size as one of our methods. What I'm actually going to do is I'm going to create a new property called get size X. And that's going to be talking about ourself, or the instance of ourself. And then we're just going to say return self dot size 0, and then we'll do the same thing for get size Y. This is going to be the second property in that list. There we go. This just makes life a little bit more, it makes it a bit more readable while we're down here playing with this method. So we're now going to change this to get size X. That's also going to be get size X on all of these. So north, south. Now we can say get size Y, but we need to, we'll come back to that. So get size Y. Okay, so we now know what the Y coordinate of our middle tile vertically is going to be. So now we need to make some changes here. We're just going to say Y is going to be there. And we're doing the east at the moment. So we're going to say get size X -1 for the first tile. So what we're saying is our middle cell on the right hand side of the screen, where that is going to be our Y position, and the X position in this case is going to be the right hand most tile. So we just need to change this. So let's get size X1, Y, like so. So that's going to be our center tile. And now we're going to do the tile above it. So we just need to get rid of all of this bump. And we're going to say size X -1 once again. Same column, just a different row. And we're going to say Y -1. And then we'll copy all of that. And this is going to be Y +1. And then this one is going to be get size X -2, Y. So that's going to be the tile to the left of our reserved tile. And again, all we need to do here is copy this, paste it, and we say if west is in our exits list. Let's just bring that camera down a smidge. There we go. And we've got the same Y coordinate as we had before, but now we're going to say get size X. We don't need that anymore. We can just change this to 0 along. And this is going to obviously be changed to 1. Cool. Right. So what should happen now is when we call the get reserved tiles property, we should now get a list of all of the tiles that we cannot spawn in based on whether or not we have entrances or exits. Cool beans. So all we have to do is just here say return output list, make sure we save it, and then we'll annotate this in a minute. We also, before I forget, we need to import the math module. So I'm just going to do that here like so that we can actually use the functions from that. Oh, actually that needs to be a lowercase m. So we'll just get rid of that. Cool, that should work now. Or rather it will do if we remember to change all of the m's to lowercase, because we're trying to call something that doesn't currently exist. There we go. So now we should have that covered. So again, remembering to save our code. Oh, also, I spot the errors as I do it. So we also need to remember to put self before all of these get sizes. So well done if you spotted that. I'm sure most of you probably did. So there we go. We now have self.getSizeX on all of these. Self.getSizeY on all of the ones where we need getSizeY. Cool. Just have another quick check for any more typos. I think that's everything. So looking into our actual game running, we can just check whether this is true. So as you can see, we've got our game.gameMap.getMatrix, and if you remember from our game map, slot 2,2 has a room in it. So assuming, so as long as that room has exits and entrances in it, we should get a, yep, there we go, we've got a list. So we've got 10 along and 0, 9 along and 0, 11 along and 0, and then 10 along and 1. So we've obviously got a north entrance, and then we've got 19, 8, 19, 7, 19, 9. So we've obviously got an east entrance as well, because they're all to the right hand side of the screen. But as you can see, position 8 is the center, so 8th of the way down, which coincidentally is exactly half of 15, which our room currently is. That's our default room size. So yeah, that's actually working. That's ready to go. So that's now going to return a list of cells in which the enemy cannot spawn. Cool beans. Awesome. Okay, so now if you remember, we have our add item thing here that creates an item at a random position, and we're using this while self.getMatrix x y comma x position here is equal to 0. Now we're going to add an AND statement here, because we need to make sure that it's not only can it not be 0, but we also need to make sure that our x and y positions are not within our reserved tile list. So we also need to say and we need to make a tuple of this. So we're going to say the y position and the x position are back to front here. So we're going to say x pos, y pos, not in self.get reserved tiles, like that. So we're now saying it can't be 0, or sorry, if it's not 0, or if the cell is within our reserved tiles list, then it's going to basically just respawn it again. And as you can see, once we create a health potion object and we try to add it to the room, it doesn't throw any errors. So far as we can tell, that method is working, or that if statement is working. But what we can do is we now also need to double check that it works if we try to add an item to a specific X and Y position, that is also not a reserved tile. So what we're going to do is jump back into our code. And as you can see, we have the AND statement here. So what I also want to do is if position not get size. So this is saying if the position is not 0, then we're going to say self is not 0. What we're also now going to say is say if position. So we're now going to say if position, yes, we can just say if position in self dot reserved tiles, then we're also going to say print cell is reserved, return. Cool. So that should now tell us whether or not our method's working, because if I try to put our item within our reserved cells, hopefully it will function as intended. So right, as we can see, we've created a health potion and we have tried adding it to 10,0, which we know is a reserved tile. And then if we actually print out the matrix for that room, you can see the item hasn't been added. Now we didn't get our this cell is reserved message, but that's hardly the end of the world, to be completely honest. So let's just make absolutely 100% sure that this function, this add item XY function is still working properly. Just so that this isn't throwing us a kind of a false positive in a way. So we'll go to add item and I'm going to change my positioning from there. We'll go 10,3 because we know that is not a reserved tile. So we're saying 10 along, 3 down. We'll hit that. It's given us nothing to complain about. So if we print out the matrix now, yep, you can see 10 along, 3 down, or 4 down really, because position 3 is actually the 4th tile down. It's added that health potion object there. So we know that our check is now saying you cannot create an object in a reserve tile and you cannot spawn a mob or an entity in a reserve tile. So that function is now sorted, complete, happy days, working, everybody is all online. So that's good. So in the next episode, we're probably going to build on some more stuff. Obviously, we're going to build on some more stuff. What a daft thing to say, but you know what I mean. That will be it for this episode. That was a pretty productive bit of coding. Hopefully you followed along without too many issues. Again, don't forget to become a channel member if you want to stay ahead of the curve on all of this stuff. And I will see you in the next one. But until then, you take damn good care of yourselves, all right? Bye-bye.